In this video, we're going to take a look at Intigriti's April challenge, which was created by Strange Monkey. The rules are the same as ever, and the description is quite simple. We need to find the flag. So let's jump into the challenge. We've got a login box down here. I'm going to open the challenge page up just so we get it in full screen. And it tells us that we've got some credentials, but maybe we should try some invalid credentials first, or we could just try like admin. Let's see if there's another user. Doesn't look like there is. And you'll see why I did that shortly. Let's now enter the correct credentials that we've been given, Strange and Monkey. We log in and we've got some pages that we can view here. We can go into view details. It'll actually redirect us to this YouTube link. So I'm going to go back. Let's skip the rickroll and we can have a look at the source code and see that there was actually a script in the bottom here which is just selecting one of these YouTube links at random whenever we click on one of those buttons. Apart from that, we don't really see much of interest. We can see our web path directory here where the images are coming from. So we might want to go and try and do some fuzzing to see if we can find out what files and directories are on the server, see what other PHP files we've got. We could also have a look at the cookies. So we've logged in, we've got this username cookie called Strange, which is the username that we put in. And then we've also got this account type, which has a seemingly random looking string of letters and numbers. So it looks like that's probably got something to do with the role that we've been given. Maybe there is an admin role which can give us access to some more data on the website. And you could probably work this out through some experimentation, but there is a hint to get you there, and that's the reason that I put in the incorrect credentials to begin with. So if we go and have a look at this index error, which is when we tried to log in, there is a comment in the HTML here which says, dev to do, remember to use strict comparison. So we've got a note from the developer which indicates they're probably not using strict comparison at the moment, so that's a vulnerability that we should look into. So if we didn't know what to look for here, maybe we would just open up Google and go and search for strict type comparison PHP, and we'll find out that strict comparison is done with 3 equal signs rather than 2. So essentially, let me actually try and see, does it mention here? Here we go, type juggling. So yeah, if we scroll through the first page results on Google, we'll quickly find out that there is a type juggling vulnerability. So I'm going to narrow this down. Let's say PHP Type Juggling vuln and see what results we get. We get some write-ups about how to exploit these. Do we also have some payloads as well? Alright, let me just search for payloads, all the things, and we'll see what they've got on here. So we can see PHP juggling type and magic hashes. Go and take a look at this, and yeah, as we just saw, loose comparison is done with double equals or exclamation mark equals, and it just checks if both of the variables being compared have the same value, whereas if we use a strict comparison, 3 equals or exclamation mark and 2 equals, we're checking that both variables have the same type and the same value. And this is basically important because if we don't check the type, sometimes it will come back true or false in unexpected scenarios. And there's some examples here, so you can see it's comparing 0010E2 to 1E3, and that comes back true when obviously they're not the same values, but it's basically because PHP is trying to interpret the type. And again, we have some here, so we're comparing a string 123 to the number 123, and that comes back as true. And even 123A to 123 will come back as true because essentially it's recognizing this as a number and then it's treating this as a number and skipping out the A at the end. ABC will come back as 0, etc. And in our case, we're probably looking at an MD5 hash. We see that there are some issues here in terms of if a value begins with 0e, so you can see here if a hash computed starts with 0e or 0.0e followed by only numbers, PHP will treat the hash as a float. So we have these magic numbers which for different hash types we can put in these values and they'll return a hash that begins with 0e followed by a string of numbers. And essentially what that means is that any value which can be hashed and will result in a 0e followed by decimal numbers will always return true when compared to another one. And we essentially want to try and do that then. So we want to try and find something which, when MD5'd, will result in this 0e string. And we don't have the source code for this application, so let's just go back. We'll just assume that that's what's happening. We're testing this black box, so I'm going to put in this value. It's going to hopefully MD5 that, and then whenever we go and have a look, we've got this new page to look at. So that's pretty cool. Now we can open this up, we can view details, and actually that just takes us through to that as well. We could open the image in a new tab, and so we've got this base64 data up here. Let's also just have a look at the response. So if you go and have a look at the request, the new request to the dashboard, and you could just right click and view source as well, but there's quite a lot of base64 data in here, and essentially what we're trying to find is that a comment has been added. So you've got this h3 ID, custom image.php, try to catch the flag. So we've got a new endpoint to test out. We could have found this through some fuzzing, by the way. It was originally set to image.php and we changed it to custom underscore image, so there are two ways to get it. I don't think that's that hard to fuzz, but not as easy as image.php, which would have shown up very quickly. However, there's not really too much for us to look at here, so we probably want to try and fuzz for parameters and values here. So you can see we can do something like this, and we could fuzz these at the same time, so try and fuzz every possible value for every possible parameter, but that would be exponentially slower than fuzzing for parameters first, and then fuzzing for the values of those valid parameters. So we can do something like this, fuzz equals, and then we can basically go and fuzz this value. And normally what I would do here is basically take a copy of this request, and then we can use ffuff. So I would do like subl new request, we can paste this in here, and then we'd say, okay, we want to fuzz, and then value, you could put in a value, maybe sometimes just some string will be needed. I'm just going to leave it as that. We would save that, and then I have a bash alias set up, so ffuff-request, which you can see basically will, if we just run ffuff request with a new request file, it'll try to brute force this with this word list by default, unless we provide a different word list. And we do want a different word list. This is directories and files. So what I normally do here is use word list DL, and then we can search for a word list, and I'm going to search for parameter. And you can see we've got this one, burp parameter names. I think I've already got this on the system, so I'm going to do locate, and then we find the full path. I always forget where everything is because the sec list has so much stuff in it. And we basically then want to just do that. We do ffuff-request, and then we can paste in that word list. However, you see this doesn't come back with anything different, and I can't work out how to get ffuff to print out responses. Essentially what we want to try and find out here is what's different in the response. Is it a different length? Does it have a different code? By default it will find the different codes, but I can't find any way to get it to print or to log the response so that we can actually see what the size is. I did try just using what we have in here, 294873, and then you can do something like filter the size, so filter size 24873 was it? 294873. So we can try and filter the size of the response, and we basically want to say any responses of that size, don't print them. But you can see it doesn't print anything. And this is a problem I run into with ffuff quite a lot, and to get around this I basically use wfuzz instead. So we'll use the same word list. So I'm going to do wfuzz-w, there's our word list, and then we'll say our URL is this one here. It also uses fuzz as a keyword, and then if we were doing multiple parameters we could do like fuzz to Z, and that would do the second parameter. We just need to give it a second word list as well, and we can run that. It's going to come back basically with all the results, which is kind of what I wanted to see with ffuff, and I thought that like using a verbose mode or something would do that. I can't figure it out at all. ChatGPT doesn't know the answer, and I can't see anything on the GitHub. So yeah, if somebody wants to let me know, I'll be interested to get around that. It's something that I run into a lot and just end up using a different tool instead, but I'd be very surprised if ffuff doesn't have some way to actually show what the response body is, or the size or something. But anyway, we can see here, this is the size here. Let's have a look at wfuzz-h. Oh, I had everything in there. wfuzz-h, so we can filter the responses. We can hide responses that have a certain response code or a certain number of lines, words, or chars. or we can do it by regex. I'm going to do it by the number of chars, which we saw was I think I've got it in the background here, 294873. So dash dash HH, as you can see here, is the last option, and then 294873. You might not be able to see that, but I've got a slightly transparent terminal, so I can see that in the background. And that didn't work. Okay, I've put in the number wrong, 294753. Okay, so we're basically saying anything that has that length, don't print it. Only print something that has a different length. And you can see this one has 19, and the parameter is file. So that's cool. Now if we wanted to try and fuzz the actual files, we could go ahead and say file equals and then fuzz, and then we just change our word list to a usual word list for directories and files, and then that's a way to basically try and brute force the keys and values. But let's just have a look. We can go and do file, so we'll see what comes up, and we get this permission denied. So that is why the response length was so much shorter than the image. And when you see this, the first thing you might think about is a local file inclusion vulnerability. So maybe we can do some directory traversal, and we can say flag.txt, try some different parameters in here, etc password, etc. But there is some filtering in place. Essentially, the .. slashes are being filtered out, and there's some other checks as well, which we can't see because it's a black box challenge. So you basically just need to experiment with this. The way that we can get around it is, let me open up the challenge page again, and it's asking us to put in our credentials. Okay. Oh, I typed in the credentials wrong. Alright, so we log in. We're not admin now. Hopefully this hasn't messed up my cookie. I guess it probably has. But that's fine. Hopefully that'll be okay for now. I think we've got past that stage. And you can see in here we've got this www web images. So I'm going to take a copy of that, and then I'm going to paste this in here. And then to get around that .. slash, we're going to use .. backslash flag.txt. And here you can see that we've got this file, get contents, we've got this warning, failed to openstream, no such file or directory in app custom image. Actually, that's not quite right. We should have the image showing here, so let me just remove that slash. There we go. So that's the image showing. We'll go and have a look at the response, and we've got some base64 encoded data. So we can go and try to decode this since the image didn't display. You could use something like CyberChef or whatever your base64 decoding tool of choice is. I'm just going to echo it into base64-d. And there we get this message saying, hey Mario, the flag is in another path, try to check it here. And we've got this path. So this isn't something that we would have been able to find with content discovery. We wouldn't be able to brute force these directories. So the only way is by finding that image and base64 decoding it. But now that we've got that, let's go and have a look at it. So I'm going to just change the directory, and this will take us through to this admin page. But we get this message again, invalid username or password. It's taking us back to the index. So there's two possible ways we can get around this. Actually, the redirection isn't set up properly, so we could use a match and replace rule in burp and just replace all of the 302s with a 200. So just manipulating the response, and that would allow us to get through to the admin page. Another option is to just change our username to admin, so that's basically the check that's being done here. So I'm going to open up our cookies. I'm going to change that to admin, and I also need to give us the magic hash again, I believe. Actually, I'm not too sure if this is required, but let's do it anyway. And we'll paste this in here. We'll try and access that page again, so let me just grab the URL. Alright, we'll paste this in here. And now we get through to the admin page. So again, we can go and do our usual stuff, have a look through the source, see if we've got anything of interest. We've got this log page here, so we can go and have a look at that. And there's a little hint there, so you can see this here as well, logs. You can have a look, and it says, little hint, nah, it's not that we're all user agent. So there's a hint that there's something going on with the user agent there. Maybe we can go and have a play around with it and see what kind of results we can get. So we can go to our request in burp. Let's send that to, let me get a request for the dashboard actually. Oh, here we go, admin. Alright, so I'll send that to the repeater so we can go and play around with it. And we can put some different values into the user agent to see if we can do anything. So maybe there's a command injection vulnerability here. That's something which is quite common. The reason being, if the user agent's being written to a log or something, then the user agent is one of the only fields that doesn't get URL encoded. So whenever we try to inject whatever the command is, there's obviously various ways that you can execute commands in terms of like using backticks or using the $sign and brackets. So those things won't get URL encoded, which means we can try and enter some stuff in here. So we probably want to start off with a simple payload. In fact, probably the first thing you'd want to do is try and just create like a delay here using sleep or something, so that you can just try and make the response come back more slowly. Or you can just try and make a connection to your server. So I'm going to let's do a HTTP server to begin with. So I've got an alias set up for this as usual. Let me just show it in case anybody wants to know. There we go. So I just do web up, and that's going to serve content on HTTP port 80. So let's open up a new window, and then I'm going to do ngrok HTTP 80, and essentially this is just going to give us an external address. So this is just serving on the local host. This is obviously a site that's on the internet, so we need a site that they're going to be able to access. So we're going to take a copy of this, and it's going to forward all the requests through to our local server, which means if I try to, for example, open this up in the browser, you'll see it'll actually list my desktop directory contents, which means it's actually a good idea, really, and I'm guilty of this quite often myself, is to create like a new folder and then run your web up, rather than having it on your desktop where you might have some sensitive files. But yeah, we can see our responses in here, and we would essentially want to try and play around with what values we can put in here. So maybe we would try to do something like curl, and then we can do HTTP. Oh, I think I've already got that pasted, so yeah, we'll paste that in there. So yeah, we could try and do something like curl, and then send that across. We don't get anything back, and quite often there's some filtering in place here, so you might not be able to use spaces, but you can replace it with something like $ curly braces IFS in capitals, or you could also use like ls. Let me open this up, I can't quite remember. ls-la, let's try. Okay, yeah, so this will basically replace the comma with a space. So there's a few different ways you can do this. There's a lot more as well. You can go and have a look at some command injection cheat sheets and stuff like that. But it doesn't actually work for us. We don't get a connection back. So another thing we might want to try is see if any of the tool names are blacklisted. So we've got curl here. Let's try and insert curl in the middle. We send that, and it took a little while to get back. And we actually got a connection as well. So you can see here the 200, okay, let's do that again. Send, there we go, another 200. So it's made this request to us, and essentially what's happened there is it looks like there's some kind of basic filtering in place where it will go through whatever string is provided, and it's going to try and remove some dangerous keywords. So it goes through this and it sees, okay, we've got this word curl. Let's strip it because it's dangerous, and then let's continue with the rest of the string. But it doesn't realize that when we've removed that curl, it's actually left curl in its place. So this is something that you see with like // filtering as well for directory traversal. And maybe then we can do something like, we could say query equals, and then let's see, can we do like ls and send the contents of that across. Send that across. It doesn't look like it. Oh, I got rid of the curl in the middle. Send that across, and I think it... Okay, so it didn't actually send us any of the response there though. But that's fine. We know we've got command injection because we're able to run curl, so maybe we could just do something to try and actually print out the flag here. We can try and see what other tools we've got access to and what's running on the box. Or we can try and get a reverse shell, which is what I'm going to do. So I'm going to do netcat listener nlvp 1337, and then I'm going to do ngrok again on TCP 1337, and it's going to give us this IP and port. And what I'm going to do is, let's go and update this. Let's say we want to do netcat, and then we want to do our space IFS, and then we'll do our IP or our address, and then the same we'll do IFS for space, and then we want to do our port, which is 13308. So we'll put in our port, and then we'll do, let me copy and paste this IFS. We'll do IFS again, we'll do -E, we'll do IFS, and then we'll do bin/bash or bin/sh. And let's try and send that across. We don't get a response, which means I've done something incorrectly. Netcat. So Netcat is blacklisted. Let's do NC. So it's going to strip out the NC in the middle, but it's going to leave NC. And we click send. It's taken a long time, which is good. And here we can see we've got this connection through. So we can say, who am I? We get www data. We can list the files and directories here, and we can see we've got access to the server. And we've got this file, which is not just flag.txt, because that would have been a bit too easy, but it's our flag all the same. So you can do cat, let's just do d star, and there we get back our flag. And that has been the Intigriti April challenge. I really liked this one. I think each element wasn't too difficult, but I liked the way we chained together 3 different elements. So we had our part 1, which had the PHP Type Juggling, which allowed us to escalate our role. And we had, for the second part, we had LFI, which had some kind of WAF in place to filter out some of the dangerous characters. And then we got onto the third part where we had, it's basically like log poisoning here, right? Because the user agent is being logged here and then it's being executed from that. It's not quite the same example that you'd see in real life, where maybe it would be like the Nginx log or something like that. But it's basically simulating that. So we've got like log poisoning, and we're injecting commands into that. So yeah, type juggling, LFI, and command injection to RCE. So yeah, I hope you've enjoyed this video. There will be various write-ups. I'm going to select the best write-ups and post those onto the Intigriti Twitter. Reminder that we do these each month. That lasts for a week, and we do give out swag vouchers for the top 3 best write-ups, and 3 are then randomly drawn. And then if you create the challenge, you also get a voucher as well. So if you're interested in making a cool challenge, then you can get in touch with me on Twitter or Discord or something like that. Anyway, hope you've enjoyed this video. As ever, if you have any questions or comments, leave them down below. Thanks.